Hello and welcome. Are you interested to see how easy it is to simulate even complex fiber amplifier systems and the like with the RP Fiber Power software, and how detailed insight you get that way? This is what I will show you within a few minutes. Although we focus on fiber amplifiers here, our software is perfectly suitable for a wider range of devices, for example including pulse compressors and supercontinuum sources, or for designing passive or active specialty fibers. Let me first briefly explain why simulations are so important in this area. First of all, the devices of interest are based on complicated physics, making it challenging to understand how they really work and how to optimize them. For example, it is not easy to predict whether amplified spontaneous emission will prevent you from reaching the required amplifier gain, how nonlinear effects can mess up your light pulses, or how you can optimize system parameters to keep such things well under control. Experimental measurements can help you only to a limited extent, because you cannot look into the devices, for example seeing what happens anywhere inside the active fibers at any time. Also, measurements tend to be cumbersome. This is where a simulator helps you enormously. Simulations are set up far more quickly than a physical prototype in the laboratory, and they reveal anything going on inside, often in the form of nice and helpful diagrams. But for this to work well, your simulator needs to be of high quality. It needs to be powerful and flexible, trustworthy, and easy to handle. That's what RP Photonics has developed with a huge effort over many years. The software RP Fiber Power, the clearly leading fiber optic simulator. This is now used by many researchers and in many companies. We managed to make it not only very powerful and flexible, but also very easy to use. I quickly show you how one works with that tool. Many typical tasks are covered by our new power forms. The first step is simply to select the power form for your type of system. Let us take the one for continuous wave amplifier systems. There are plenty of input fields where you can configure your whole setup. For example, define up to 10 input signals, which can be monochromatic or broadband. Then set up the details of one or more amplifier stages, select an active fiber, its length, define pump sources, etc. We can also insert spectral filters and the like between the amplifier stages. Further down, you can configure a wide range of diagrams to display exactly what you need. Of course, the whole set of inputs can be stored in a file so that you can easily switch between such parameter sets. When you are finished, execute the simulation. This will display various calculated values in the form and also produce the diagrams. Let us quickly see how detailed insight we easily obtain. The loaded parameters are for a dual-stage erbium fiber amplifier with 3 broadband input signals at different center wavelengths. First, a few parameters are displayed numerically: the signal output powers and gains of each stage and the residual pump powers. In addition, the diagrams reveal a lot more. Let us have a quick look at a few of the available diagrams. Here you see how the optical powers and the excitation densities evolve along the active fiber of the first stage. It is easy to change some of the inputs, execute again, and check what has changed. We can quickly switch to the second stage. Note that it would be close to impossible to get all these data experimentally. This diagram shows the evolution of signal powers through all stages. Of course, we could modify various details, for example use logarithmic axis scaling. Here are the simulated output signal spectra of stage 1 and of stage 2, and the wavelength-dependent gain. Here are the ASE output spectra. This here shows with a color map how the signals evolve in the system. Another diagram shows that for ASE. One can make many more diagrams than shown here, for example for checking what happens if you vary a certain parameter such as a signal input power or wavelength, a pump power or wavelength, or a fiber length. You see that you easily get very detailed insight not only for expected outputs, but even into the internal workings. So you can analyze that far more than you could ever do with even the most sophisticated measurements. And by varying some parameters, you can quite quickly find out how to optimize your design. When you later build your amplifier system based on that, you will be far more likely to get what you wanted. One more thing is to understand that and how we manage to provide uttermost flexibility with our power forms. Normally, a form-based user interface is easy to use, but very much limited in flexibility. It simply offers only what is built into the form, and a software developer can never anticipate every possible detail needed by a user. But we have found elegant solutions for that challenge. I'll show you a few examples. What if you need an additional curve in a diagram which the form does not offer? Simply insert one line of script code in the form. We are happy to help, of course. If you need a whole additional diagram, you can insert several lines of script code. If you need some sophisticated further data processing, for example with writing to files in some given format, again, edit script code will do it. We will develop that for you if you can't do it yourself. And what if you need additional input and output fields in the form for an extended simulation model? Even that can be done. For that you make a tailored version of the power form, possibly again with our help. By the way, the power forms and all their calculations are themselves defined by script code, which you can inspect and modify. These very powerful scripting features, well integrated into the nice user interface, are what gives our products unique flexibility as others can usually not achieve. If you are interested, we will be happy, for example, to show you in a joint video session how quickly one can set up a simulation and produce very interesting and helpful results. You are welcome to contact us, for example, through the contact form on our website.